Hello, today we are going to start our next lecture. It is called the types of surface modifications. So, in this particular lecture we are going to discuss about the various types of surface modifications. So, before going to start this, I first let me tell you that what is the purpose of doing the surface modifications, what benefits we are going to do, why we are going to do, and then what are the methods generally we are adapting to do the surface modifications. So, first let us know the definitions of the surface modifications. So, it is an act of modifying the surface of a material by physical, chemical or biological characteristics different from the ones originally found on the surface of a material. So, from that particular definitions we can understand that when we are talking about the surface modification, so we are doing to modify the surface, right. If there is any problem or maybe if there is any contaminations or maybe if there is any impurities or maybe any kind of hazardness on the surface of the bodies. So, we are trying to modify it. By which method we are trying to modify it, that mechanisms is known as the surface modifications method, and whatever the materials we are going to deposit or maybe we are going to put on the surface of that particular material, that should be the different from the base material. Now, what is the purpose of the surface modifications? So, first one is enhancing the anti-corrosive properties. In the last several slides I was discussing about the wear, I was discussing about the abrasions, I was discussing about the surface hazardness or maybe some kind of chemical attacks. So, when we are making a materials from a material scientist point of view, when we are making certain kind of materials, we are using the materials for various applications. So, when we are using those materials, maybe we do not know that what purpose we are going to use, maybe we are keeping that materials into some chemical environment or maybe the atmospheres where maybe some kind of reactions can be done. So, due to that maybe some kind of corrosions can take place onto the surface of that particular material. So, just to remove or maybe delete or maybe give some protections onto that surface of that particular materials, we are going to do the surface modifications. Next, improving the electrical conductivities and the optical properties. Maybe my material is a insulator material, but by doing the coating of any conducting materials, we can make that material as a electrical conductor, or maybe we can use it for some optical purposes too. Next, increasing the bioactivities, maybe that material can be used for some biocompatible material, either I can use that materials because for some maybe some medical applications. So, when we are talking about nowadays we are talking about some kind of metals or maybe some kind of polymers which we are going to use for our biomedical applications, like for hip replacement, maybe elbow replacement, maybe any kind of joint replacement. But sometimes what happened, maybe that material is not readily accepted by our body. So, what we are going to do, we are trying to do certain kind of coatings on that particular materials by which that can be material can be accepted to our body. Next, improves adhesion properties, so that stickiness or maybe the rather we can say it, maybe I am doing the coating on particular material so that it should not be come out like a barrier, any kind of barrier layer we can put onto that particular material. Improves component lifetimes, resistant to aggressive environments, produce biocompatibility, that should be biocompatible. Nowadays we are very much concerned about the pollutions or maybe that whatever the pollutions is coming from the material waste. So, we are trying to make certain kind of materials which should be biocompatible, so that when after finishing its life, when we are putting or maybe throwing that material into the environment, it should not create some kind of toxic gases. Then create permanent wettability, produce the hydrophobic characteristics. So, these all are the also some kind of applications or maybe some kind of purposes which we can get from the surface modifications. So, from the left hand side figure you can understand there are some benefits which can be included for surface modification process. What are those? First one is called the surface chemistry control, then uniform 3D treatment, long treatment lifetime, roll to roll compatibility, specialty chemicals and cast off additives. So, these all are the different benefits, or maybe rather we can say advantages by using the surface modifications method. And right hand side you can see how or by which properties we can analyze the surface modifications. Says let us start from wetting, then leveling, scratch resistance, matting, abrasive resistance, block resistance, glow enhancement, soft fill, water repellency, adhesions and slip control. So, there are numerous applications by which we can control the material properties, we can change the material properties, we can change the acceptance of that particular materials to us, so that it can behave something totally different than the previous one, or maybe it can show some better properties in terms of physical properties, chemical properties, or maybe the mechanical properties. So, in this particular slide we are going to discuss about the different technical resources for the surface modifications. So, in a layman term I can say that there are various types of sources. By adapting these sources we can do the surface modifications techniques. So, mainly these all are the background of the surface modification techniques. So, first one is called the plasma treatment. Maybe that plasma treatment you can adapt for doing the surface modification. So, this is a one kind of resource for your perfect model, or maybe the corona discharge, then parylene coating and the photolysis. So, in depth in the next slide we are going to discuss about these 4 surface technical resources. Next we will discuss about the plasma. So, as we know that plasma is nothing but the 4th state of any matter. So, if we agitate those materials it can shows the 4th state, that generally normally we know that solid state, liquid state and the gas state, and plasma is called the 4th state of particular material, that is beyond these 3 normal states. So, plasma is a reactive treatment process where positive and negative ions, electrons and radicals react and collide as long as an electrical potential difference exists. What is the surface advantages? Surface chemistry is highly selective and unique ability to treat a material 3 dimensionally. So, the simple thing is that I am having some target, I am agitating that target so that it can release certain kind of ions or maybe the electrons, then we have to collect these ions and electrons and we have to do the bombardment onto that material surface. So, by which the surface chemistry or maybe the surface properties can be changed. So, what are the disadvantages? High plasma system price and low rate of productions, large chamber size and higher power, because for this particular case we need some controlled atmospheres, we need some inert gas, we need some controlled temperature or maybe the ambient conditions, so that we have to maintain that constant atmosphere all over the experimental time. So, that is why it is little bit expensive and the machines are also too sophisticated and too large also. Plasma treatment helps to microclean to enhance the surface weighting of additives, functionalize groups to improve surface energy, establish a hydrophobic and hydrophilic properties. So, by changing the material properties or maybe by doing the surface modifications by the ion bombardment or maybe the electron bombardment, we can change the material properties. So, from this particular figure you can see that before plasma treatment the poor adhesions of paint on device. So, how many times we are putting the paint onto that, but it is not sticking, means its adhesion properties is very less, it is coming out. So, when we are doing some kind of etching types or maybe some kind of scratching type onto that material by the plasma treatment, after that we find that simply the paint is sticking with the materials, that means adhesion properties of that particular materials has been enhanced. Next one is called the corona discharge, rather we can say that it is little bit kind of modified versions of the plasma treatment. So, from these particular things we can understand that corona discharge is plasma at standard atmospheric pressure. This plasma is produced by high voltage and the close proximity of 2 metal plates in atmosphere. So, from this particular case you can understand that we are having one electrode, we are having 2 electrodes, one is acting as a positive, another one is acting as a negative. In between that we are generating the high voltage difference or maybe the potential difference, and we are having some target materials. That target materials is divided into 2 ions and then one of the ions is just coming to your surface, that opposite materials, just like that opposite magnetic fields can attract each other, something that plus ions is directly going to the minus ions and they are doing the surface modifications. So, here it improves the properties of a surface to provide a longer lifespan, improve surface bonding, improve corrosion resistance, but there are certain drawbacks too. What are those? Lack of surface chemistry selectivity. Most Corona systems are designed to operate in open air conditions, limited polymer choice, treatment in 2 dimensions. That means whatever the target material I am taking, that should have the compatibility with the base materials. If there should not be any compatibility in between that, or maybe there should not be any reactions in between that, that material will not stick with the base material, so that the material adhesion properties will not be increased or maybe not going to be changed. Advantages: price of purchasing a system for in-house treatment. Systems are robust and easy to maintain and easy of use. Then next one is called the Parylene coating. So, Parylene coating, it is also a one kind of rather we can say that one kind of chemical type of modifications methods by which we are trying to do some kind of chemical reactions over there. Then we are having some substrate that is known as the solid dimer, and we are taking the gas molecules of, or maybe some inert gas, or maybe that inert gas we are generally here taking, or maybe we are trying to do some kind of chemical reactions in between that, so that some gas is generating. That gas is directly coming through this chamber and it is coating your materials. So, by doing these methods we are calling it as a Parylene coating. So, it is a conformal surface coating that protects sensitive device by providing a barrier layer against environmental contaminants. So, simply it is doing one kind of wrapping onto the material surface. It significantly improves the performance and durability of manufacturing components by extending lifetime coating to a decade or even longer. So, Parylene coatings improves device longevity due to resist flaking, abrasions, chemicals, solvents, moisture. So, just it is giving a layer so that any chemical environment or maybe the environmental moisture can't react with your material, base material. Strengthens molded plastic magnetic components, provides a barrier against leaching or blooming, improves lubricity through a low frictions, because you can, it may be some kind of slippery nature, so that it can be used for as a lubricating in between the surfaces. Offers excellent thermal stability in high temperature. That material is having that capacity or maybe the capability that it can withstand the higher temperature, so that it can be used into the high temperatures, remains chemically and biologically inert. So, these all are the different properties for Parylene coating. And the next one is called the photolysis. So, in a single word I can say that this is the combinations of plasma as well as the corona. So, it combined principles of corona and plasma. Such systems use high voltage to excite gas in an emitter, which then radiates to the surface of a polymer. Radiations is then fine tuned to chemically modify a polymer to receive most additives, paints, coatings and links. So, from this particular thing slide you can understand that is controllable. That means the thickness of that particular coating can be controlled by us. Not only that, the reactions in between the materials and the coating materials and the base materials, that also can be changed. Means if you want to you going for different materials, that you have to change the precursor. So, advantages: high throughput treatment of stable polymers and elastomers, efficient and effective due to the specific wavelength emitted by the radiation source. Electricity or charge sensitive device are easily and safely treated. Systems can be easily designed to fit on nearly any conveyor systems, moderate cost related size and shapes. So, it depends upon what type of applications you are going to do. So, based on that you can choose any of them. So, considerations: offers very selective surface chemistry, requires standard atmospheric operating conditions, line of sight, or maybe the 2-dimensional things we can do it over there. Next, it is a just rather we can say that this is a one kind of examples, that by which adapting which functional groups and for doing or maybe solving which problems we can do the surface modifications, and what are the characteristics or maybe the what are the remedies or maybe the what are the results we can get by adopting this kind of functional groups. Say let us take one example, suppose we can adopt the hydroxyl functional groups. Generally we can get it from the alcohols itself, examples is ethanol, glycerol, sugars. The characteristics is we can get the polar characteristics or maybe the hydrophilic characteristics of that particular material, or rather we can say if we take the amino NH2. So generally we are getting a class names is amines, we are getting these materials from the amino acid. So what kind of materials properties we can get? We can get the polar, hydrophilic and weak base. Then like that methyl, so methyl generally we can get from the fatty acids, oil, waxes. So we can transfer the material from to non-polar and hydrophobic. So from this particular example you can understand that suppose I am having some materials which is polar, easily I can make it into the non-polar materials, or maybe I am having the materials which is showing the hydrophobic nature, I can make that materials into the hydrophilic nature. Now there are certain common problems and remedies by which we can do some kind of modifications, or maybe by surface modifications we can repair some material surfaces, or maybe we can change the material properties. What are those? Like polymeric well plates and cell culture trays. What is the applications of that particular material? What type of problem generally we are getting? We are facing the problem like polymer properties inhibit or interfere with reagents or cultures. Yes, of course, because polymer is having a high affinity to react with the chemicals, or maybe to react with the any kind of chemical environment. So just try to do some kind of modifications, we can observe or maybe we can stop that problem, so that that polymer will not be reacted with the any chemical environment or maybe with the chemicals. So enhancement in surface properties by grafting carboxyl, amine or maybe the hydroxyl groups. Same thing we can go for some kind of semiconductor materials or maybe electronic devices like PCB boards, flexible circuits, spotting or in some kind of encapsulations. So non-uniform anti-shocks and anti-corrosion coatings or poor wear bonds, these all are the problems generally we are facing in our day-to-day life. So what we are going to do? We are doing some kind of plasma cleaning to promote uniform and consistent coating on an atomically clean surface. So first we have to see the problems, then we have to know the remedies, then we have to do it accordingly. In the next slide we are going to discuss some kind of latest techniques generally we are adopting for doing the surface modifications. So what are those? First one is called the attachment of bioactive functionality. Generally we are doing this kind of modifications for the biomaterials. So what we are doing? We are having some kind of materials, biomaterials. So biomaterials is having some kind of functional groups on the top of that, right, at the surface. So if we keep that material for a particular time, either that material will degrade or maybe that material will react with the environment and its properties can be changed. So by solving these problems we are going to add some kind of biodegradable or maybe bioactive materials to the surface, so that by chemical reactions that material can react with that materials and that can do certain kind of coatings onto that material. So surface modification techniques enhance biocompatibility of material without changing the bulk properties. Biocompatibility is heavily dependent upon surface properties as well as the interactions between the surface and cells and or proteins or between cells themselves. Bioactive functionality can be attached through large extracellular matrix, protein or maybe fragment bioactive coatings, covalently bound short signaling domains, chemi-absorptive short signaling domains, physioactive short signaling domains. So these all are the different, or maybe rather we can say the various techniques generally the biotechnology people are adopting, and from that particular figure you can understand that we are having the base materials and top of that we are attaching some kind of bioactive molecules or maybe bioactive materials, so that that material can be coated or maybe it should be insulated from the any kind of environmental attack. Next is called the intensify porosity of surface. Generally we are doing this kind of techniques for the drug delivery. Nowadays people are talking about the targeted drug delivery, right. We are trying to adapt some kind of materials and we are trying to put those through the medicines, and then we want to see that what is the effect in it. Nowadays people are using some kind of nanofillers. So when we are adapting those materials, we are trying to see we are trying to do that material should have different pores or maybe that different holes, so that the medicine can be easily absorbed in between the pores and holes, and when it will go into our stomach, so automatically that medicines or maybe that drugs can be released easily, so that it can go to the affected portions. So the purpose of a drug delivery system is to devise methods that enables delivery of a therapeutic agent that maybe have suboptimal physiochemical properties in biological tissues. Drug carrying nanoparticles or smart drug carriers enter through pores to the cells where the drug or gene is further released and activated. So some cases that maybe that drug can't reach properly. So what we are doing, we are trying to make certain kind of microfilars which is having some pores. So we are injecting the medicines in between that pores, and that microfilars can easily go to the affected parts, and while it is reaching to the affected parts, easily it can release the drugs, so that it can do the remedy at that particular point. So few techniques associated with physical energy are listed below. So like this, electroporations, magnetoporations, thermoporations and the sonoporations. So physical energy like electric field, magnetic field, temperature, ultrasound. There are certain disadvantage also, irreversible electroporations, cell dealt with high fields. So like till now these all are the methods which you are using from the past, but now we are trying to modify those methods by doing some kind of material or maybe by preparing some kind of materials which is having the higher porosity. Next we will discuss about the classification techniques which generally we are going to adapt for the surface modifications. What are those? It is divided into two parts. One is called the physical modifications, another one is called the chemical modifications. Then physical modifications also divided into two parts: change in surface metallurgy and addition of surface layer and coating, and chemical modifications is change in surface chemistry. So this is the whole idea about the surface modifications. So in our coming slide we are going to see that what are the physical modifications and what are the chemical modifications generally we are going to do. So like thermal treatment, mechanical processing, other environmental treatments, by adapting all these methods we are going to do the surface modifications. And the right hand side you can see some kind of cladding, thermoreactive diffusions, electroplating, hot dip coating, ceramic coatings, organic coatings and lining. By changing the surface layer or maybe the surface chemistry, we are going to do the surface modifications. And also the chemical reactions is like that we are going to do by pack cementations diffusions, ion implantations, thermochemical diffusions, chemical / electrochemical conversions, laser alloying. So these all are the different techniques generally we are adapting for the surface chemistry by changing the surface or maybe rather we can say that by changing the surface chemistry we are doing the surface modifications. And in summary, if we discuss about the whole slide what we have discussed till now, so the thing is that here we have discussed into two parts. One is called the surface modifications is mostly done through by which method: change in surface metallurgy, change in surface chemistry, additions of a layered surface coating, attachment of bioactive functionality, intensifying porosity of the surface. Then these surface modifications results for improvement in physical chemical properties. So these is the applications or maybe this is the things why we are going to do the surface modifications: improvement in electrical and electronics properties, enhancement in durability and reliability of the workpieces, applications in various fields like aerospace, automobile, electronic device and biomedical applications, etc. So there are n number of applications generally by we can do by these surface modifications, or maybe that we can change the surface properties, by that our material can be accepted to any environment. Thank you.